Friday. You will have a self-check this Friday and then another self-check next Wednesday. You'll have two.
Wait, what?
2 self-checks.
Oh.
4 homework assignments, and that's it. Test on Friday. Okay. This unit, the entire unit, we're talking about special segments in triangles and some special properties that they have. So every day we're going to talk about a different segment in a triangle and different properties that it has. Before we do that, let's skip the warm-up. Let's just go straight into the lesson. Before I go through the 2 new segments that we're going to learn today, there's one definition that I have to talk about. It is equidistant. A point that is the same distance from one line as it is to another line is equidistant. So equidistant is same distance between. Okay? So if we look right here, since xy is the same length as y, or xz, goodness, we would say that x is equidistant between y and z, because it's the same distance away. Okay? For points, it's really easy. To measure the distance, you just measure the length of the segment in between.
Is there like a special notation for equidistant?
There is not, no. Good question, though. So for points, you just measure the length of the segment in between. For the distance between a point and a line, because this is kind of what we're going to talk about today, this distance has to be measured by the length of the perpendicular segment. Meaning all these perpendicular lines, that represents distance. This segment, this red one, would not represent the distance between that point and that line. Okay, we need the perpendicular segment. Go ahead, Reagan. That's not like, keep going. That's not like the super, most important thing. So don't worry about it too much, but this property is the reason why a lot of the stuff we do today works. Okay, because we measure distance with perpendicular lines. Okay. First definition, first special segment that we're going to talk about is a perpendicular bisector. If you look on your cheat sheet, this is like one of those definitions that's typed up, or one of those vocab words that's typed up. These 5 are your special segments. We'll do 2 today and then 1 each day for the rest of the unit. Okay? So, someone remind me, what does perpendicular mean? Because we know what this word means without even... It crosses at, 90 degree angle. Okay, so we have some segment crossing something at a 90 degree angle. What does bisector mean?
It perfectly cuts it in half.
It cuts it in half. So what we have here is a segment, or a line, like line M, that goes through another segment at a 90 degree angle, and it cuts it in half. So those 2 pieces are the same. They're congruent. So that's a perpendicular bisector. It's perpendicular and it bisects. Robbie?
Stop it.
That's our first special segment. We're going to look at an online application to see kind of what properties this segment has. So...
Shut up.
Easy, Ryan.
Easy, pumpkins.
Okay. So what I've done in GeoGebra, and you have access to this on Schoology if you needed it. Hey, listen. What I've done is I drew segment AB, and then I put point C as its midpoint. So meaning this length is the same as this length. AC is the same as CB. That's step 1. Step 2 is I made this segment DC perpendicular. So it's perpendicular and it's a bisector because it's hitting this midpoint. Okay, so what I've drawn is a perpendicular bisector. We're going to figure out, well, what do we notice first about the distance between point D and the end points of the segment?
Straight line.
It's a straight line. What's the length of those segments?
Equal.
They're equal. Okay, so we have that point is equidistant from the endpoints of the segment. No matter what, we can move D up and down that perpendicular bisector, and it's always going to be the same. So that's our first kind of theorem. We noticed in here that AD was equal to BD, or that they were congruent. So we recognize that these two segments are the same length, no matter what. That is our perpendicular bisector theorem. And just to preface, a lot of these theorems and a lot of these segments look the same. The key is how we label our pictures. Okay? So for the perpendicular bisector theorem, it says if a point is on the perpendicular bisector of a segment. So in this case, point C is on the perpendicular bisector CP. So C is on CP, which is a perpendicular bisector. That's what we need. We need a perpendicular bisector and a point on it. If we have that, then that point is equidistant from the endpoints, meaning this length AC is the same as this length CB. Okay. So therefore, AC is easy. AC is congruent to BC, or the lengths are equal. Does not matter which. But if you see a perpendicular bisector, the algebra behind it is that you're going to set these two lengths equal. Okay? So if you see this situation, 8th hour, focus. If you see this situation with a perpendicular sign and bisection, then we have congruent segments. Okay? So if you see a perpendicular bisector, you have congruent segments. The converse is also true. If these segments are congruent, so all I did was take this picture and flip it upside down, really. But if AD is congruent to BD, then D has to be on the perpendicular bisector. On your cheat sheet, and you might want to make a mental note of this, on your cheat sheet, do not waste the room or the time writing both of these. Write this one, draw the picture, and then maybe underneath it say converse is also true. But there's no need for you to write both of these paragraphs in both pictures. Do one, and then just say converse is true. Okay?
Mr. Cruz, can you tell him to stop talking? I literally didn't say it.
Okay. Leave him alone. Okay. Leave it. It's okay. We're good now. Leave each other alone.
He's quiet.
Okay. Let's do some examples. The algebra behind this is super simple. I don't want you to overthink it. You're just setting two things equal for all of these problems. So, first step, you have to figure out what type of segment you have. Well, I see a right angle and two congruent pieces. So what type of segment or line is SQ?
Segment bisector.
Yeah, SQ is a perpendicular bisector. So that means all those theorems that we just learned about work. They're true. Okay? So if I have a perpendicular bisector, I have not only these two congruent segments because of my midpoint, but what other two segments are congruent? What?
RQ and PQ.
RQ and PQ, yes, from the bisector part.
SPSR.
SP and SR are also the same because S has to be equidistant from the endpoints. So if SR is equal to SP and SP is 6.8, what's SR? If my orange ones have to match, what's my top orange one?
6.8.
6.8.
Y'all are both wrong.
Okay?
Charlotte, stop talking.
So again, all we did, turn around, Rowdy. All we did was set these two lengths equal. That's it. Over here, on the next one, we're told that those two lengths are equal. So, if those two lengths are equal, by the converse, what type of segment or line is FH? Yeah, it's not a trick question. We've only learned one. Perpendicular bisector. Because these segments are equal. So since our 24s are the same, it's a perpendicular bisector. So this segment is going to be bisected. Half of it's 9.5. What's the other half? 9.5.
No, that's not. That's incorrect.
And then it says we have to find the whole thing, EG. How would I find EG? Add them together. 9.5 plus 9.5. We get 19. What's up, Charlie?
Is there a difference between a perpendicular bisector and segment bisector?
No.
Yes. All perpendicular bisectors are segment bisectors. The only difference is the right angle or not. Like this is a segment bisector, but this is a perpendicular bisector. You know what I'm saying, Charlie?
Yeah.
Great question. If you did not hear Charlie's question, I'm going to say it again because it's a really good one. Segment bisectors and perpendicular bisectors are not the same. They're similar. They have one of the same properties. They both hit the midpoint. But perpendicular bisectors have to be perpendicular. Segment bisectors may or may not be perpendicular. We don't know.
What if they are perpendicular?
If they are, then it's a perpendicular bisector. Okay? That's the only difference, the right angle or not. Okay. Last one. First, do we have a perpendicular bisector? Yay or nay? Yeah. Isaac.
Whoa, Isaac, get back in the class.
Listen.
Just
Okay. We have a perpendicular bisector. We have the right angle, and we have those two congruent symbols. So we say that BD is a perpendicular bisector. And now we can use my theorems. If I have a perpendicular bisector, I know two things. I know these two segments are congruent because of the midpoint. What else? What other two segments do I know? AD is congruent to CD. Boom. Notice, my picture is nearly the same for every single one. So, I can say that AD is equal to CD, and I can set their lengths equal to each other. So AD is 5x, and CD is 3x plus 14. He's fine. Okay. How do I solve this for x? Charlie, how do I solve? First step.
Well, I just subtracted 3x.
Okay, I agree. So we get 2x is equal to 14. Ryan, what's my next step?
On that one?
So you don't know.
Yes, I do.
You don't know.
Leave him alone. I called it him for a reason.
Okay.
I'm here. 2x equals 14.
2x equals 14. You divide by 2.
Divide by 2. And we get x is equal to 7. However, that is not my answer. It asked me for AD. Caden, how do I find AD? Here's AD.
5x. You have to put in 5x.
Yeah, plug in 5x. Perfect.
It's just those mental errors we got.
Hey, listen, the side conversations, Robbie, these side conversations need to stop. Okay, for AD is 5x. All I'm going to do is plug in 7 for x. And I get AD is 35. That's my final answer.
Why do we do that?
Because the question asked. Up here it says what's AD. Okay, that is your first type of segment or a perpendicular bisector. Question? Down here, AD equals 35. Any questions about perpendicular bisectors?
Put it away, Robbie. Bro, put your shoes on, bro.
Okay. Your next segment you actually know about. We just haven't talked about it in triangles. It's an angle bisector. If we remember from Unit 1, an angle bisector cuts an angle in half. So here I would say YW is an angle bisector. And if I told you that this small angle was 30, what would you tell me this other angle was? 30. They're both 30. And the whole thing would be 60. Okay?
It was never out of the window.
That's an angle bisector. It cuts an angle in half.
Is there no more?
If we look at some properties of it, again, what I've done is create an angle bisector. So AD is an angle bisector. Notice how those two smaller angles are the same. And what I've also done is make these two segments perpendicular so that they represent the distance between D and this line, and then D and this line. So that's why those little perpendicular boxes are there. They represent the distance. As we drag D, what do we notice about the distance between D and AC and AB? What do we see? They're the same. This segment length is the same as this segment length. And since that segment has a right angle, we can say that D is equidistant to those lines. Okay? So, what we just did was we said, okay, DE was perpendicular to AB. The whistling needs to stop. Your eyes should be up here, not on Jordan.
Quit it, Ryan.
Hey, I said your eyes should be up here. Don't throw a fit. Calm down. It's all good.
Holy temper tantrum.
Okay.
What?
Listen. So, step one, we noticed that these were perpendicular. They represent the distance. Mhm. Like, is that good?
Yeah.
Okay. So again, those segments, their length represents the distance between that point and the line. And what we recognized was that these two distances are the same. So for angle bisectors, we have congruent angles and two congruent segments. Okay.
Weird. Let's mess with this. She's trying to be a girl.
So again, we say D is equidistant from those two lines. So anytime you see an angle bisector, you should think these two segments are the same length. Okay?
Lock in.
I think you need to sit right up there for that.
I think this seating chart is not going to work. U5.
Isaac.
Okay.
You pulled your shirt, but we're gonna talk about
Yep. Let's try to make it through for the last 20 minutes. Ryan, we're done. Isaac, we're done.
We need 20 minutes.
Can you go up?
Yeah, dude, let me teach. No, I'm not going to go up. You were sleeping. Okay.
My fault, they're being weird. I decided to sit myself out.
Okay. That's our first theorem for angle bisectors. Listen, first theorem for angle bisectors. A point on your angle bisector is equidistant from the sides of the triangle. So since D is on an angle bisector, we would say D is equidistant from those two sides of my angle. So AB and AC. But what you need to know is if you see a picture like this, you're setting these two segment lengths congruent, equal. Okay? Setting two things equal. The converse is also true. So again, on your cheat sheet, don't put both of them. Just write down converse is also true. It's a while. So in this case, for the converse, if you have a point on the interior of an angle, so on the inside between your two sides, and it's equidistant from the two sides of your angle. So in this case, we're given these two congruent pieces here. So we're given that DB is equal to DC. And if that happens, then you know that D is on the angle bisector. So it goes both ways. But if you look, this picture is like super, super similar to these pictures. You have to be super careful about what type of segment you're actually. Why are we talking across the entire class?
I'm not, I got
Not your job, Ryan Nichols. Not your job. Okay.
stuck on me. Good.
So, again, I'm giving you a fair warning. All of the pictures in this unit look so similar. Be careful about which segment you're actually looking at and what theorem goes with that segment. Like here, we know it's an angle bisector because it goes through the angle and it cuts it in half. That's different from like this one because we didn't know if it cut this angle in half or not. Okay? We were more worried about cutting this segment in half. But the pictures are similar, so just be careful. Okay. But again, for angle bisectors, you're just setting two things equal. First step is to figure out if you have an angle bisector. In this case, do we know if FJ is an angle bisector? Do we know?
Yes.
Yes.
Why?
Why yes? You're right if it's yes, but do we know why?
Wait, hold on.
Because it's
Where
splitting
are
through
we?
an angle.
Eh.
Because.
On page GEO.
Because by the converse of my angle bisector theorem, since these two segments were the same length, since they were both 7, it has to be an angle bisector. So you could either be given congruent angles or these two segments congruent, and you have to know it's an angle bisector. Okay? So if it is an angle bisector, what would the measure of angle GFJ be? If JF is cutting this angle in half, what's the measure of my pink angle?
42.
42 degrees. Questions on that one? That one uses the converse. Okay. This one, again, we have to figure out, do we have a perpendicular bisector or an angle bisector? What do we think for SQ here? Is it going through an angle or is it going through a segment? What's PQR? Is this an angle or a segment? It's an angle. So SQ is cutting that angle in half. Here's my two congruent angles. Those two pink angles. So SQ is an angle bisector. And now we can use the theorems. Okay? If SQ is an angle bisector, what do I know about SP and SR? They're equal. You'll see this pattern all the time. For most things in this unit, you're just setting two things equal. Typically the things that go like this and like this point shape, okay? So we're going to set 5x equal to 6x minus 5.
X equals 5.
Yeah, we could either subtract the 6x and then divide by -1, or subtract the 5x and add 5. Either way, you get x is 5. The question, though, asked to find SR. How do I find SR? Plug it in. So 6x minus 5 turns into 6 times 5 minus 5. 6 times 5 is 30.
Yeah.
Minus 5, 25.
Very good, Ryan.
So again, this one used the actual theorem. We got an angle bisector, so we set the segments congruent. In this one, the segments were congruent, so we made it an angle bisector. Okay? Questions on those two? Okay, we're going to bump it up a notch. What this has shown, I know, this picture, you'll see it a lot. If you look, there's pictures just like it on my poster, a bunch of them. I know, you're going to see it a lot. Let's look at what we have here. This piece right here, NB, is it an angle bisector or a perpendicular bisector?
Perpendicular.
No, it's angle.
It's cutting this angle, right?
Look forward, bro.
It's cutting this angle in half, so it's an angle bisector. What about NA?
That's
Angle
also-
Angle bisector. What about NC?
Angle bisector.
What about NF?
Angle bisector.
What's it called?
Perpendicular bisector.
Right.
Neither. It's just perpendicular.
Perpendicular.
It doesn't show us that it's bisecting, so that was a trick question. NF really means nothing to us right now.
Means nothing.
Good.
No, I said it.
Okay,
I said it first.
hold on. We're going to set up what we have. It tells us that ND is 5x minus 1. It tells us that NE is 2x plus 11. I'm going to take this big picture and turn it into something that looks more doable, like the ones up top. So I'm just essentially going to cut off the bottom half of this triangle, okay? I'm going to draw, here's B, here's D, E, here's N. This is the setup that we have, okay? If I have an angle bisector, what do I know about these two pieces? They're equal, they're congruent. And those two pieces were my 5x minus 1 and my 2x plus 11. So I'm going to set them equal. Okay. I'm going to subtract the 2x and add the 1, just in one step. Subtract 2x, add 1. Questions on how to get 3x equals 12. Now what? Divide by 3.
5 by 3.
We get x is equal to 4. Was my question asking for x?
No.
No, it's asking for NF. Which of these do I plug x into? The 5x minus 1 or the 2x plus 11?
Either.
Either. It doesn't matter. They're the same. We just made them the same. So plug it into either.
You think they're gonna get us out of school early?
No.
Dude, we have 10
What do you
minutes.
think?
That would have been a long time ago.
Dude, we have 10 minutes.
But we get 19. We get 19 for NF. Again, NF was just that piece of that angle bisector theorem, and those three are all the same. So I could have plugged it into either two. The last question uses some creativity. It says, can NG, so this piece right here, can that be 18?
Stop.
Hold on. Let's think this through. I'm going to draw this triangle right here because it deals with NF, which I had was 19, and it's asking if NG could be 18. Based on my picture, what type of triangle is this?
Right angle.
It has a right angle. Okay, it's a right triangle.
I said it first. No, I didn't.
Does anyone remember from Algebra 1 or earlier this year what we call this segment, the side directly across? Hypotenuse. So, NG is the hypotenuse of right triangle NGF. Does anyone know a special property about the hypotenuse?
No.
You probably haven't learned it explicitly yet. You said something good, Charlie. What'd you say?
It's long.
It's long. It is the longest side. So is that going to work if my hypotenuse is 18 and my other side's 19? No. So since it's the hypotenuse, it must be greater than 19. 18 is not greater than 19, so my answer is no. That one just required some creativity because we had to look at this right triangle. Knowing that the hypotenuse is the longest side, that comes from the very last section we'll do this unit. Okay, so we'll do that on Monday. Okay? Questions, comments, concerns?
So I already have a question.
You said my name right?
Okay.
I have a question, all right?
Probably.